Hi everyone, today we will be performing JC2 Experiment 9, which is about organic qualitative analysis. The aim of this experiment is mainly to familiarize ourselves with the various distinguishing tests for the organic functional groups. So we are looking at test number 3, which is about the test for alcohols. The two main tests that we will be doing will be the KMNO4 test and the iodoform test. So for the KMNO4 test, what we will do is we will add about 1 cm depth of sulfuric acid in a test tube. And we will add 1 drop of KMNO4. Take care not to add too much because the aim of this test is to observe the decolorization of the purple KMNO4. If you add too much, it will be much harder for it to decolorize. So I have 3 test tubes of KMNO4 solution, which will be adding 1 drop of 3 alcohols to each of them. The first alcohol is ethanol. Ethanol is a primary alcohol, so we expect to see decolorization of the KMNO4. So I'll add about 1 cm depth of ethanol in, and we are going to place it in the water bath right here. Next, let's do that for the second alcohol, which is propan-2-ol. This is a secondary alcohol. We expect to see decolorization of the KMNO4 too. And finally, a tertiary alcohol, 2-methyl-propan-2-ol. Tertiary alcohols are resistant to oxidation, so we don't expect to see decolorization of the KMNO4. So while waiting, let's perform the iodoform test. For the iodoform test, we'll be adding about 1 cm depth of sodium hydroxide to a test tube, followed by 1 cm depth of iodine solution. The iodine is decolorized because of a disproportionation reaction with sodium hydroxide. So this is normal, there's nothing to worry about. After that, what we'll be doing is adding a few drops of each alcohol to the solution. So this is ethanol. Ethanol has the iodoform group, so we expect to see a yellow precipitate of iodoform appearing. Yes, look at the precipitate appearing. Okay. I have 2 other solutions of alkaline aqueous iodine prepared already. We'll be adding the next 2 alcohols one by one. So this is propan-2-ol, which has the iodoform group 2. Look at the precipitate appearing again. That's your iodoform, the yellow precipitate. And last, we have the tertiary alcohol, 2-methyl-propan-2-ol. This alcohol doesn't have the iodoform group, so we don't expect to see any precipitate at all. And indeed, no precipitate appears. Okay, so now let's do a quick check on our 3 test tubes in the KMNO4 test. As you can see, the decolorization is observed for ethanol, propan-2-ol, which can be oxidized by KMNO4 because ethanol is a primary alcohol and propan-2-ol is a secondary alcohol. But the last alcohol, 2-methyl-propan-2-ol, is a tertiary alcohol which is resistant to oxidation. That's why the KMnO4 solution still remains purple. Okay everyone, still on experiment 9, organic qualitative analysis. We are looking at test 4, which is about the distinguishing test for carbonyl compounds. We will be performing 3 main tests, which is the iodoform test, the tolerance test, and the failings test. These are 3 of the important tests that we need to know for carbonyls. So for the iodoform test, what we will be doing is the same thing, same as the alcohol test. We will be adding about 1 cm depth of sodium hydroxide in a test tube. After that, adding about 1 cm of iodine solution. Here we have 2 carbonyl compounds, ethanol and propanol, both of which have the iodoform group. So we expect to see yellow precipitates for both carbonyls. Let's try ethanol first. Let's see if a precipitate appears. Oh, look! Yellow precipitate of iodoform again. I've prepared another solution of alkaline aqueous iodine, which I will now use for propanol. Again, we expect to see a yellow precipitate. Look at the precipitate forming. Yes. Exactly the same observation as ethanol. Now we will be doing the failings test. For the failings test, what I have on hand is some failings solution. Failing solution is an alkaline solution of copper 2+ complex with tartrate ions. That's why you see the intense blue color is due to a complex ion formation. So what we will do is we will add about 1 cm depth of failing solution to a test tube. And we'll be adding our carbonyls in as well. So I'll be adding ethanol first. Ethanol is an aldehyde. Aldehydes can be oxidized. So when we add the carbonyl in, we expect to see a brick-red precipitate. There's no precipitate at the moment because the oxidation reaction needs energy. So I'll be placing the test tube in a hot water bath right here. I have another solution prepared, failing solution, and we'll be adding some propanol to it. Propanol is a ketone. Ketones are resistant to oxidation. So when we add the ketone to failing solution, even with warming, we don't expect to see any brick-red precipitate forming. So I'll just place my water bath by the side and we will observe. The right test tube is for ethanol and the left is for propanol. Now we will do the tolerance test. So what I have is a boiling tube which I will be adding silver nitrate to it, about 1 cm depth. After that, we will be adding sodium hydroxide to the silver nitrate. Silver nitrate contains Ag+, which will form a silver oxide precipitate when we add sodium hydroxide. So that precipitate is brown in color. Just a few drops will do, 2 or 3. You can see the brown precipitate forming. We will be adding aqueous ammonia to dissolve the precipitate. Make sure when you add the ammonia in, all the precipitate is dissolved so that the solution is clear. Then you will know that ammonia is in excess and you have prepared Tollens reagent. So I have prepared another identical Tollens reagent in another boiling tube. I will be adding ethanol to it. Ethanol is an aldehyde. You know that aldehydes can be oxidized, so we expect to see a silver mirror. Oh, look at the silver mirror forming. It's not as shiny, but it will do. Now let's try for propanone. Propanone is a ketone. The ketones can't be oxidized, so we do not expect to see any silver mirror at all. Nothing is happening. So some time has passed. Let's do a quick check on what we have for the Fehling's test. Let's look at the water bath. Wow. What we have on my left is the test tube containing propanone with Fehling's solution, and the test tube on my right. This is the brick-weight precipitate that you are looking for when your aldehyde gets oxidized by Fehling's. This is the test tube that contains ethanol. Thank you. Hello everyone, we have come to the end of experiment 9. We are now at section 4, organic qualitative analysis. The aim of organic QA is to identify certain functional groups that are present in your reagents. So here I have with me 4 reagents, Fa1 to Fa4, and what we want to do is to identify the functional groups that could be present in these reagents. We will be doing a series of tests. Some of them have already been done, so all we need to do is to complete the remainder. The first test we'll be doing is the 2,4-DNPH test. We'll be doing that on Fa2 and Fa3. So the 2,4-DNPH test confirms the presence of a carbonyl group. We will expect to see a precipitate, usually bright orange in color if there is a carbonyl group. So what I will do is add about 1 cm depth of Fa2 first into a test tube, followed by adding some 2,4-DNPH. Just a few drops will do. We are looking for presence of a precipitate, whether it forms. A few drops, and the solution is still clear. There's no precipitate. Just to play safe, I'll be warming it a little bit in my water bath right here. Let's do the test now for Fa3. So I have some Fa3 here. I'll be putting 1 cm depth inside the test tube. After which, we will be adding some 2,4-DNPH. Just a few drops will do. Wow, look at that. There's an immediate appearance of a bright yellow precipitate. Well, it's a little bit orange, so we can say it's a bright orange precipitate too. That's the key for organic QA. You have to be flexible with the observations in practice. So just to check on the water bath now, as you can see, there is no precipitate that's formed. So for Fa2, no precipitate, that means there's no carbonyl group present. But for Fa3, we have a precipitate, that means you have a carbonyl in Fa3. The next test we'll be doing is the tolerance test. The tolerance test on Fa3. So I'll be preparing my tolerance reagent right here. We'll be adding some silver nitrate, about 1 cm depth. So I'll be pouring it into this boiling tube right here. After that, we'll be adding some sodium hydroxide. That will cause silver oxide to precipitate. As you can see, the brown silver oxide has precipitated. After that, we'll be adding some ammonia in excess to re-dissolve the silver oxide to form the silver diamine complex. That is essentially tolerance reagent, silver diamine. Let's add a little bit more. As you can see, the solution is now clear. So we'll be adding Fa3, about 1 cm depth of Fa3 to our tolerance reagent. Tolerance reagent tests for the presence of an aldehyde group. If we have an aldehyde in Fa3, what we expect to see is a silver mirror. Tolerance reagent is an oxidizing agent, so it oxidizes the aldehyde. That reaction needs energy, so I'll be placing the boiling tube in my water bath right here. Oxidation of aldehydes involves breaking of strong covalent bonds. That's why heating is required. So while waiting, we'll be moving on to the next test in part C, which is the KMNO4 test. So here I have with me 2 test tubes that contain sulfuric acid filled with 1 drop of acidified KMNO4. Notice the pale pink color of the solution. When you are doing this test, you do not want the solution's color to be too intense, because that will take a bit more reagent for the KMNO4 to decolorize. Just pale pink like this will be very good. So we'll be doing the KMNO4 test on Fa2 and Fa4. I have both my test tubes and I'm going to put some Fa2 into the one on my left and some Fa4 into the one on my right. Oxidation reactions require heating, so we'll be placing both test tubes in the water bath. Let's check on the tolerance test that we did just now. As you can see, there's no silver mirror. That means Fa3 does not contain the aldehyde group. So while waiting for our KMNO4 test results, we will move on to part D, which is the iodoform test. So here I have 2 solutions which I have filled with aqueous iodine. You can see the brown color of the iodine. I will then add sodium hydroxide to give our alkaline aqueous iodine. As you can see, the brown color of the iodine is decolorizing. That is normal. After which, we will add Fa1 and Fa4 to our alkaline aqueous iodine. So I will add Fa1 to the test tube on my left. As you can see, a bright yellow precipitate appears. You can say pale yellow too. Let's try for Fa4. Adding Fa4 in produces no precipitate. So we can conclude that Fa1 has the iodoform group, but Fa4 doesn't. So now let's do a quick check on our KMNO4 test results. Wow, so both solutions have decolorized, the one for Fa2 and the one for Fa4. Okay, so we are done with part 4 of experiment 9. Thank you.